Okay, hello everyone. I just re-downloaded the update for Zoom. Thanks for being patient.
Update.
Yeah, so I updated it and okay, so let's go back to the problems. Hopefully it's better now. So let's go on to the homework. For some reason okay, so this works. Does anyone still need the link? Or does everyone have the link? Okay, I'll just assume everyone has it. So let's go on to here. So A, B, C, D, and E, each one.
It. Oh, now I have it.
Oh, you have it? Okay. So this is the homework. Calculators are allowed as usual, and please keep your answers somewhere. So for problem 1, you have A, B, C, D, and E, each weigh 10, 20, 30, 40, and 50 pounds each. They do not know how much each one weighs. So A could weigh 30, 40, 20, or 50, or it could weigh anything. We don't know which one. All we know is that you can't have two of them weighing the same amount. So you can't have B or C both weighing 50 pounds. So those are the rules. And then let's just put back the equations that we had. So A and E together are heavier than B and D. So A plus E is greater than B plus D. And E plus D is equal to B. Let's look for the easier one to solve. The second one. E plus D is equal to B. So B could be 20, 30, 40, or 50. And we have to remove one of those. You know why? Because if B is 20, then both E and D have to be 10. And you can't have two of them weighing the same amount. So we'll remove 20 from the list. So B could be 30, 40, or 50. Let's try out each of these. If B is 30, then we have E also. Because E is on the larger side, we'd prefer E to be the larger one. So if you had A plus E is greater than B plus D, then you would have E is equal to 20 because you want it to be larger. So D is equal to 10. With that, we have A plus 20 is greater than B is greater than 30 plus 10. And we have two choices for A. We can have 40, A is equal to 40, or 50. And that would pretty much be our answer, which is super simple. All you have to do is just pick one equation to choose, and you have to pick the right one so you don't waste time. And then if you have equations where something equals something else, but you don't know the exact values, the correct way to do these is just guess and check, or use a better form of guess and check. So it can be 40 or 50, which means that C is equal to 40 or 50. If A is 40, then C is 50, and if A is 50, C is 40. That's the answer to problem 1. Now for problem 2. This is exactly equal to one of the problems. This is exactly the same as one of the problems we had last time, except the distance between the holes are different. So why is it still not showing up? Can someone just share right now? Someone just start screen sharing to see if I can fix this. Okay. Thank you. Thank you very much. Let's go back into here. I'll just try make sure I don't remove this. are up top. So how many centimeters is the belt longer if it is only closed in the first hole instead of in all 5 holes? So if it is in the first hole, that means that the belt would end, and if you cut off all the extra ends, that means the belt would start here. Oh, it would start here and end here, not here. That's the first hole. And then the distance between this, it can be anything. So let's just make it easy on ourselves and pick the easiest number that we can use. We're going to use 10. The distance between these is 10. So if it's only closed in the first, hold on, never mind. If it's only closed in the first hole, that means that if it made a loop, then only one hole would be covered up, which has to be the outsidemost. So it's these. And we have to find the total distance. We keep the center is equal to 10. So between the 5th hole on the left and the first hole on the right is 10. And we have 4 increments of 5.5, so 5.5 times 4, and that is equal to 22. We also have 4 parts of 3.5 over here, and 3.5 times 4 is equal to 14. We have the total length, if it is only closed in the first hole, is 22, plus 14 plus 10. And that would equal 46. All right. So if it is closed in all 5 holes, that means that if you cut off the extra bits, you'd have a loop that starts here. Let me change the color so it's a little more understandable. It starts here and it ends here. And that's only 10. So the other one is 10 plus 0, because you have nothing else, is equal to 10. So how many centimeters is the belt longer if it is only closed in the first hole instead of in all 5? You just subtract 10 from 46, so 46 minus 10, and the answer for number 2 would be 36. So that is problem 2. Now let's go on to problem 3. This one none of us have done before, and we shouldn't be very familiar with it, so it should be probably the hardest. The rooms in Kanga's house are numbered. Eva enters the house through the main entrance. Eva has to walk through the rooms in such a way that she enters a number higher than the previous one. Through which door does Eva leave the house? Okay, so this one is a guess and check one. Remember, guess and check is very important when you're doing Math Kangaroo. Also, making drawings would make problems way easier. For example, this one, if they didn't give you drawings and only told you the numbers in each square, then you would have lots of trouble. Okay, let's start here. And I'll put circles showing where we started. So let's start, we always start at 1. And we can only go left, right, down, or up. Let's go right. So we start at 1 and then we go to 2. 2 is less than 4, 6, and 10. No, less than 4 and 10. But if you see we go to 10, that means that all of these numbers over here, 10 can go to none of these numbers because it's larger than all of them. And you're only allowed to go to the number higher than the previous one. So let's go to 4. And the pattern that we'll see here is that we always want to go to the lowest higher number. So if you're on 16 and you have choices between 17, 20, and 22, well, microphones just change automatically. Can you still hear me?
Yeah.
Okay. Thanks. And I'll remove the chat. Just move this. So which door does it? Okay, let's move these back to normal. And let's draw. We go to 6. What's the highest? The lowest higher number? We have 9 and 10. We obviously go to 9. Okay, so we also have the where are we at currently? We're at 9. So we can go elsewhere. We're at 9. We can choose between 8 and 12. We cannot go to 8, so we must go to 12. And here you see we're stuck at a dead end. So let's start over. Instead, let's try going to 3, the second lowest higher number. 3, we can go to 4. Then we go to 6. But then from 6, you can't go anywhere because 5 is lower than 6. So let's start over, but stay in the same direction. So we go 1, 3. And instead of going to 4, we can try going to 5. Then we can go to 6, 7. Oh, and you see where this is going. We go to 8, 9, and 10. And then we can exit. And guess where we exit? We exit at D. Okay, so that's all of the problems. For 3, just make sure you keep track of where you are and where you are headed. That's also very important for Math Kangaroo. This we have already done. This is this time, so let's look at the problems. Number 24. From above, the corridor of a school looks like in the diagram. A cat walks along the dotted line drawn in the middle of the room. How many meters does the cat walk? Okay, so we have this sort of diagram, and let's just draw it larger. Cover the whole place, and then we have, so everything in white. We have something like this. Actually, let me clear it. We'll draw it with lines. So we have this, this. And then we start at the end. We go to here, go to here, and go to here. Now I just need the measurements. So 8, 36, 40, 26, 28. Here's 8, 36, 40, 26, 28. What? 20. Let's put 6 here. And 28. Okay, so those are all our numbers, and it always stays in the middle, which is what you see here. It always stays in the middle. And the way we can find this is we find all this whole length, so from here all the way over to here, and then subtract this part. And what we know is that this part is half of this part. Let me draw that in red. This part. And let's first find what the length of the red line is. We have the upper part, 36, which is shorter, and the lower part, 40. We want the difference between that, which is equal to the red part. So 40 minus 36 is 4. Therefore, the red line is 4, and this line over here is 2. So this whole line, all the way down the middle, must be equal to 40 minus 2, which is 38. So that's our first one. Then we have to find the height. Okay, so let's erase. No, that wouldn't be very useful. Okay. Let's keep going. We want this part now, this vertical part, which means it has to be equal to this plus this, and then minus all of that. And if we look over on the sides, That's each of the widths, the heights of these corridors. And we have to divide that by 2 because it always travels in the middle. So 8 divided by 2 is 4. 6 divided by 2 is 3. And if you look at it, the total height must be equal to 20 over here. Here's a straight line and then 6. 20 plus 6 is the total height, which is 26. So 26 minus 3 minus 4 gives you this middle bar, which is equal to 19. Okay, so now we're on the final part. This final part must be equal to, oh wait, the width of this is always the same. And we already have the width. The width is 4, so this line that I'm drawing right now has to be equal to 4. Which means that this right here is 2, half the width. And we can move that line up to here. So this is 2. And the top length, 28 minus 2, is equal to 26. So this here is 26. And we add up all of these lines. 38 plus 19 plus 26. And that, if we add that up, we have 19 plus 26 is 45, plus 38 is 83. So the total length that the student has to walk is 83 meters, and that's one of the answer choices for 24, which is E. So your answer for 24 would be E. Okay, so now we're on to problem 23. One of the 5 children, Alex, Bartek, Cora, Danny, and Emil, have eaten a cake. Alex says this, Bartek, all of them say that, and one of them must lie, which means that all the others are saying the truth. So which child has eaten the cake? Let's keep going through. This is just guess and check. We'll start with saying that Alex is the one that is lying. So Alex ate the cake, which means that all the others are telling the truth, which means that Bartek ate the cake. And that can't be possible because only one of the children ate the cake. There aren't 2 cakes to be eaten, so Alex cannot be the one that is lying. Let's go for Bartek. Bartek did not eat the cake, so Bartek did not eat cake. And Alex did not eat cake. Neither has Danny or Emil. But Emil has to be true because Bartek is lying, so Alex has eaten a cake. And you see you can't have Alex both eating and not eating the cake. So Bartek cannot be lying because it is not possible for someone to be eating and not eating a cake. Okay, let's go to Cora. Cora is the liar here. So Emil has eaten the cake. But we see here Bartek has eaten cake. This can't be possible because you can't have 2 people eating the cake, as we have figured out from 23. So as we figured out from saying that Alex ate the cake, so that can't be possible. Let's go on to Danny. Danny says, I did not eat a cake. So Danny ate the cake because Danny is lying. Here we're just choosing that Danny might be the liar. But then Bartek ate the cake. And that's also not possible. So the only one left is Emil. Emil is the liar. So let's see who ate the cake from what Emil has. So Alex has not eaten cake. And then what Alex says, Alex did not eat cake. Bartek ate the cake. Danny did not. Emil has not. So that's our answer. Bartek ate the cake. So for 23, your answer would be B. Okay. We're on to 22. This one is extremely easy. So, several triangles makes a star. What is the minimum number of triangles she used? I'll just trace out these triangles. This question, I don't know why it's here. It's super easy. So here's the red triangle. We have the red triangle. I'll switch colors to blue. Here's the blue triangle. You could stack these like that. And there's one more triangle up top, so we'll just make a yellow triangle. 1, 2, 3. And the minimum is always 3. So for problem 22, your answer would be B, 3 triangles. That one is incredibly easy. I don't know why it's this far. Okay, so problem 21. There are 15 animals on a farm, cows, cats, and kangaroos. We know that 10 are not cows and 8 are not cats. How many kangaroos live on the farm? So we have 10 animals that are not cows and 15 animals total. So we have 5 cows. Because 10 are not cows, 5 are cows, and those add up to 15. Also, with the same logic, 8 are not cats. So 15 minus 8 is 7 cats. If we add these together, the leftover is 3. So 3 kangaroos. The answer for 21 is B. This is also very easy. Math Kangaroo is incredibly easy if you know the correct strategies, which are guess and check and making a drawing. Okay, so 20. Here the strategy is to just record important parts. Let's take the center. You see the center here? The gray is over the dark gray. No, the gray is behind the dark gray. And if we flip it over, that means the light gray has to be above the dark gray. And that's all of these. So all of these are possible. Okay. So we can't look at the middle alone. Let's also look at the top. The dark gray is above the light gray. And if you flip that over, that is exactly the same. So the light gray is over the dark. Which choices are those? You have C and you have A, where the light gray is over the dark gray. Let's look at the bottom one now. So the bottom here. Let me erase this too. So the bottom one. The light gray is over the dark gray. So if we flip it over, we have the dark gray is over the light gray. The dark gray is over the light gray on the bottom. And that is not true for A, so we'll erase A, but it is true for C. So your answer for problem 20 would be C. This problem is also very easy. You just make sure that you know what you're doing and you know what you're looking for. So you just find certain points that would always stay the same and use examples. And examples for problem 20 are very useful. Okay. So problem 19. The pages of a book are numbered with 1, 2, 3, 4, and 5, and so on. The digit 5 appears exactly 16 times. What is the maximum number of pages the book can have? Okay. This one's a little harder. So let's try to write it out. The number 5 appears 16 times. So 5 can appear, for example, in 15. It can appear in 85. It can also appear in 51. But what's very interesting is that you can also have 55. Here, 5 appears twice. So we'll go on that logic. Let's start. So we have 5. We have 15, 25, 35, 45. And so that's the first 5. That's 5 here. Then we go into the 50s. So you have 50, 51, 52, 53, 54. That's 5 right here. And we have 55. That is 2. We go from 56, 57, 58, 59. That's 4. Okay, so it appears 16 times. And what we have so far are 5, 5, 2, 4. Those add up to 16. Okay, so what's the largest number that's possible? We can have We can also keep going. We have 60, 61, 62, 63, 64, but we cannot have 65 because then the number 5 would appear 17 times. So the largest number would be 64. So 64. And that's our answer for problem 19. And yes, 64 is one of the choices. So this one, instead of trying to figure out like how many times the number 5 appears, just as they asked in the question, what you can do is list out the number of ways that 5 can appear. And always be aware, don't forget that 50, 5 also appears 50, and 5 appears twice in 55. That's very important. Okay. We are on to 18. Wait, does everyone understand how I did 19? Because this, I think, it would be the hardest one in the whole competition. But we solved it really quickly by just knowing that we can list out the numbers, and listing it out gives us the answer. And don't forget that you don't stop at 59. You can keep going on to 64. Okay. So 18. Anna uses 32 small gray squares to frame a 7x7 big picture. How many small gray squares does she need to use to frame a 10x10 big picture? Okay, so let's see how she got the 32 gray squares to frame it. On each edge, there has to be 7. 7 here, 7 here, 7 here, and 7 here. Okay, so all the edges are covered. But you can't forget the corners. The corners are also 1, though they're not next to any of the parts in the picture. So 1, 1, 1, and 1. So add that all up, we get 32. So how does this have to do with what we're trying to solve? This is not a 10x10 picture. Well, we know how to find how many that we need for the 10x10. So I'll show you how we do it. So we have 10 on each side. So we have 10 gray squares, dark gray squares. 10 here, 10 here, 10 here, and 10 here. And then using what we have from trying on the 7x7 square, we also have the corners. 1, 1, 1, and 1. And what do you get when we add these all up? We get 44. So your answer for 18 would be C, 44. We are going through these questions super fast. I'm guessing this one was just a really easy competition. Okay. Let's do 17, and then we'll go on to problem strategies. So each shape represents exactly 1 digit. Some of the digits in each row is stated on the right-hand side. What digit does the star stand for? Okay. What is it? Okay. I'll reopen this. We're on problem 17. Okay. So each shape represents exactly 1 digit. From this, we see circle, circle, circle is 12, which means that 3 times circle is 12. That's the easiest one to figure out. So circle is equal to 12. Then we have circle plus star plus heart is equal to 15. Oh wait, circle is not equal to 12, so circle is equal to 4. And we have circle plus star plus heart is equal to 15, which means star plus heart is equal to 11. When doing this problem, don't just settle for using numbers. You can for getting the exact value of each one. You can get expressions. So star plus heart is 11. Then we have star plus heart is 16. Oh, that's very interesting. We have star plus heart is 11. Star plus heart plus 2. Another heart is 16, which means that we are running out of time. Which means that the heart is equal to 5. Heart is equal to 5. And from this, we have star is equal to 6. And that is E. So our answer for 17 is E. Okay. Let's just bring up a blank screen. So here's the problem strategies because the competition is very soon. The first problem should be very easy, 1 to 15. Try to do as fast, try to do well. Do these well because they're pretty important, and if you get one wrong, that could take points off your score. So shoot for everything is perfect and correct, and always check your questions. Then 16 to 24. Do when 1 to 15 are perfect. You want 1 to 15 to be perfect, as I said before, and once you've checked or even double checked them, go on to 16 to 24. 16 to 24, do 1 by 1. Always do these 1 by 1. Once you finish a question, double check that. Then go on to the second question, double check that. Then the third question, double check that. And do these 1 by 1, different from how you did 1 to 15. Okay, so this is the main way that you'll be doing the problems. And the other way, the other thing is that the strategy, the tricks to remember. The best trick is always draw a diagram. If you don't give a diagram, then draw one. The second one, guess and check. This is very important and it's just usable in a lot of different ways. For example, the one where there were 5 people each saying whether they ate or didn't eat the cake and who else might have eaten the cake. So I just guessed, did A lie? And if so, let's see if it makes sense. Did B lie? No. And if all of the first 4 didn't lie, that means the last one had to lie. Then the third best strategy, if you can't use draw a diagram or guess and check, is just make examples. For example, if you have a problem where you're given, actually never mind, just always make examples and make it easy on you. If they give you have 2 numbers A and B must satisfy this thing, just make A and B equal to 0. If they're not necessary for the answer, then make them whatever's simplest to do. Don't make them 7.5 or anything. That's very tough to work with, or 299. Just make them 0, 1, 10, anything that's super easy to manipulate. Okay. So remember these for the competition. For 1 to 15, do as well as you can. 16 to 24, do them 1 by 1. Once you have everything before that perfect. And then the tricks, draw a diagram, guess and check, make examples, and make it easy on yourself. Okay. I'll stop sharing. Good luck, everybody. And I'll just stop the meeting now. Does anyone have any questions? Okay, then. Bye, everyone.
Bye, thanks.
Thank you.